Hello students, welcome back to our class on YouTube channel. Class 12th mathematics class is going on. In previous video we saw some questions of second order derivatives. That is the topic going on. We have so far discussed 5 questions from exercise 5.7 in NCERT class 12th region, right? 5.7. Exercise 5.7 is running. Next question is question number 6. That is e to the power of x into sine 5x. We have to find second order derivative. Two functions are there. E to the power of x is one function and sine 5x is another function. They are in product. So definitely we have to apply product rule, UV rule. Yesterday in previous video we saw UV rule. d by dx of UV rule is u into dv by dx plus b into du by dx. U dv by dx plus b du by d. First function as it is differentiation of second plus second function as it is differentiation of first. Now to solve this question you have to do the same. Take the given function as y is equal to e to the power of x sine 5x. This is the given function. Y is equal to e to the power of x sine 5x. Now to differentiate, first to get the second order derivative you have to first get the first order derivative, then differentiate it again, you will get second order derivative. So differentiate with respect to x. Differentiate with respect to x. When we differentiate with respect to x, differentiation of x will be 1. If we differentiate with respect to y, the differentiation of y will be 1. Differentiate with respect to what? The differentiation of that variable will be 1 always, right? Okay, now, so y1 will be, that is first order derivative, or you can write y dash or dy by dx. UV rule. We are going to apply UV rule. U as it is, differentiation of v, differentiation of sine 5x. Sine 5x is there, right? So it will be cos 5x. Differentiation of sine is cos, and the same angle will be attached to it as it is here. But it's chain rule. We cannot just do this. We have to differentiate 5x also. It's a composite function. If it is just sine x, then the differentiation of sine x will be cos x, right? Differentiation of sine x will be cos x, and no need to differentiate x again because differentiation of x with respect to x will be 1. Even if we differentiate x, it will be 1. Cos x into 1 will be again cos x. But if angle is other than x, as it is 5x here, we have to differentiate that also. So we have to differentiate 5x also. So to differentiate 5x, we know 5 constant as it is, differentiation of x is 1. 5x, 5 as it is, differentiation of x is 1. So this is the differentiation of sine 5x, right? Sine, differentiation of sine is cos, and then differentiation of 5x is 5 into 1 plus first function as it is, differentiation of second is over, plus second function as it is, sine 5x, b as it is, differentiation of u is here e to the power of x. We know differentiation of e to the power of x is e to the power of x itself. So that y1 will be e to the power of x can be taken as common. You can take e to the power of x common. It will be 5 cos 5x plus sine 5x. 5 cos 5x plus sin 5x. E to the power of x is taken common from both terms, right? Now this is first order derivative. Now second order derivative, we have to differentiate again. To get the second order derivative, again differentiate with respect to x. Again differentiate with respect to x. So y1 will become y2, y1 will become y2, y1 will become y2, second order derivative. This is again in the form of uv, u into v, uv rule. First function u as it is, differentiation of second, differentiation of this. Differentiation of this will be 5 constant as it is. Differentiation of cos 5x will be minus sin 5x into differentiation of 5x is 5. Right? Again it is composite function. Differentiation of cos is minus sin, then differentiation of 5x is 5. So plus sin 5x differentiation will be cos 5x into, then differentiation of 5x we have to do, that is 5. Right? So u as it is, differentiation of v is over, plus v as it is, that is 5 cos 5x, 5 cos 5x plus sin 5x as it is, v as it is, differentiation of u. E to the power of x differentiation is e to the power of x itself. We have already seen in our formulas, differentiation of e to the power of x is e to the power of x only. Differentiation of e to the power of x is e to the power of x only. So it will be e to the power of x. Right? U differentiation of v plus v differentiation of u is over. Now again from these two terms we can take e to the power of x common. We have e to the power of x here and we have e to the power of x here. So e to the power of x is common. So what will be left? This becomes minus 25 sin 5x plus 5 cos 5x. This will also become plus 5 cos 5x plus sin 5x. Right? That will be y2 is equal to e to the power of x into minus 25 sin 5x plus 1. That will become minus 24. Minus 25 plus 1. That will become minus 24 sin 5x. This 5 cos 5x plus 5 cos 5x will become 10 cos 5x. This is the final answer. Let's see the next problem. The next problem is e to the power of 6x into cos 3x. This is also a product of two different functions. Product of two different functions, right? E to the power of 6x cos 3x. Write down y is equal to e to the power of 6x into cos 3x. E to the power of 6x into cos 3x. Differentiate with respect to x. Differentiate with respect to x. Right on, always differentiate with respect to x. If we differentiate with respect to x, it becomes y1 is equal to uv rule again. First function as it is, differentiation of second, that is minus sin 3x into 3x. Differentiation of 3x will be 3, right? 3 into differentiation of x will be 1, 3 into 1 is 3. First function over, then differentiation of second, plus second function cos 3x as it is into differentiation of first e to the power of 6x, e to the power of 6x as it is. Differentiation of e to the power of x is e to the power of x itself. Now here we have 6x, not just x. Differentiation of e to the power of x is e to the power of x. In fact, we must differentiate x also in multiplication. So but it will become differentiation of x is 1. Therefore we do not do. 1 will not make any difference, right? But here 6x. So differentiation of 6x is 6. Differentiation of 6x is 6. If it was just x, no need to do. But it is 6x, right? We have to do. It's composite function, chain rule. So first function as it is differentiation of second plus second function as it is differentiation of first is over. So that becomes y1 is equal to, we can again take here e to the power of 6x common. E to the power of 6x is common. So what is left? Minus 3 sine 3x plus 6 cos 3x is left. This is, and 6 cos 3x is left. Right? Again differentiate. Again differentiate with respect to x. So it becomes y2 is equal to second order derivative. Y2 is equal to, again it is uv, first function, second function. First function as it is, u as it is, differentiation of v, this one, right? Minus 3 is constant, kept as it is. Differentiation of sine 3x is cos 3x into 3. Differentiation of sine is cos, and differentiation of 3x is 3. Plus 6 constant as it is. Differentiation of cos 3x is minus sine 3x into 3 again. Because differentiation of cos x is minus sine, cos is minus sine, and 3x is 3. Right? That is over. U dv by dx plus v, this is v, this bracket is v here, right? Second function. So we can keep it as it is, that is minus 3 sine 3x plus 6 cos 3x as it is, v as it is, into differentiation of u, e to the power of 6x, that will become e to the power of 6x into 6 again. Differentiation of e to the power of x is e to the power of x, into power is 6x, so we have to differentiate power also. 6, differentiation of 6x is 6 constant into x differentiation 1 over. That's right? Okay, then y2 is equal to, again we can take e to the power of 6x common here. So it becomes e to the power of 6x is common. It becomes, this will become minus 9, 3 into 3, 9 cos 3x. This becomes minus 6 into 3, 18 sine 3x. Then plus into minus is minus. This becomes 3 sine, 6 is there, 6 3s are 18. This 6 will also multiply to it, right? 18 sine 3x. Then plus into plus is plus. Then this 6 into 6 is 36 cos 3x. Right? Now, that will become y2 is equal to e to the power of 6x into minus 9 cos plus 36 cos 3x, minus 9 3x plus 36. That will become 27 cos 3x. Right? Minus 18 is minus 36 sine 3x. Right? We can do one thing here. We can take 9 common here. If we take 9 common, 9 e to the power of 6x. From 27 and 36 we are taking 9 common, it will become 3 cos 3x minus 9 4s are 4 sine 3x. This can be the most simplified answer. So we got y2, second order derivative. Question number 7 is over. Note down and practice, right? Let's see the next problem. Next problem is question number 8 from exercise 5.7 in NCERT textbook. 5.7, second order derivative topic is going on. Tan inverse x. Tan inverse x. This is the question, right? Now let's take y is equal to tan inverse x. Y is equal to tan inverse x, right? Differentiate, as we are always doing the same thing. Differentiate with respect to x. Differentiate with respect to x. So it becomes dy by dx is equal to dy by dx, differentiation of y is dy by dx, or you can write y1 or you can write y dash, no problem. Differentiation of tan inverse x is very easy. We know differentiation of tan inverse x is 1 by 1 plus x square. Differentiation of tan inverse x is 1 by 1 plus x square. Derivative of tan inverse x is 1 by 1 plus x square, right? So 1 by 1 plus x square. 1 by 1 plus x square. Now, this is first order derivative. We cannot simplify more. Keep it. Now differentiate again. We have to get the second order derivative. We have to get the second order derivative, right? So to get the second order derivative, we differentiate again. Again, differentiate with respect to x, right? So it will become d square y by dx square. D square y by dx square. That is second order derivative. Differentiate this. This is in the form of constant divided by x raised to n. Consider this as x, this all as x. We have formula constant divided by x raised to n. Differentiation of constant divided by x raised to n is we have to multiply the constant in numerator by the power and change the sign and add 1 in the denominator, add 1 to the power, right? And then we must differentiate x also in multiplication. We must differentiate, but that makes no difference because differentiation of x is 1. But here we have in place of x we have 1 plus x square, right? We have this. This is x for us and its power is 1. Its power is 1 here, right? So what will happen? This is k constant and this is x and this is n. Power here is n, that is 1, right? So what is the rule? Change the sign. If it is positive, make it negative. If it is negative, make it positive, right? It's positive, so it will become negative, and this power here 1 will multiply with this 1, so it will become 1 only. 1 ones are 1 divided by 1 plus x square. Add 1 in the power. It's 1 here, so it will become 2 into. Now we must differentiate 1 plus x square. We cannot leave. In case of n divided by x raised to n, k divided by x raised to n constant, we multiply this by changing the sign, n into k divided by x raised to n plus 1 into, we must differentiate this x, but it becomes 1, that's why we do not do it. 1 makes no difference. But here it is 1 plus x square, base is 1 plus x square, so we have to differentiate. Differentiation of 1 is 0 plus, what is the differentiation of x square? It is same as x raised to n. Multiply this 2 will multiply here, it will become 2x. Differentiation of x square is 2x, right? This is complete. Now, therefore, d square y by dx square is minus, this becomes 2x divided by 1 plus x square whole square. This is the final answer. This is the second order derivative of tan inverse x. I hope you all understood these problems. Practice these problems and we'll solve more problems in next video. Thank you for watching.